have tested our first order factor model, okay, and we had EMP, TO, and LEX, and we said that, well, we have these 3 items for EMP, 4 items for TO, and we had 3 items for LEX. We have these 3 items for LEX, and we have these covariances that we model between the latent factors, first order factors. Now, once you do this, there are 2 things that come that we need to check next, which we call as convergent validity and discriminant validity. Now, in order to compute these, there are 2 indices that are computed. One is called as the composite reliability, which is denoted by CR. Okay, and the formula for CR is, it says, it goes like, you have I varying from 1 to k, number of items in the construct, summation lambda I whole square divided by summation lambda I whole square, again for all I, plus summation 1 minus lambda I square for all. Okay, so this is basically the formula. And what does composite reliability say? Composite reliability is again just like Cronbach's alpha, it is a measure of inter-item consistency after accounting for measurement errors. So now this CR is computed from the measurement model. What is lambda I? Lambda I, remember, it is always standardized factor loading. It is always standardized factor loading. So how do we, what is it that we do to, so if we have, for example, let us take this example of EMP. Let us say it had loadings of 0.6, 0.7, and 0.8. These were the 3 loadings of EMP. So what will be the composite reliability for EMP? So we'll write it as composite reliability for EMP is going to be 0.6 plus 0.7 plus 0.8 summation lambda whole square divided by 0.6 plus 0.7 plus 0.8 whole square plus summation. So we'll add this 1 minus 0.6 square plus 1 minus 0.7 square plus 1 minus 0.8 square. So this gives us an estimate of measurement error associated with each of these items. Lambda is the loading, so 1 minus lambda square is the estimate of the measurement error. And this number, just like Cronbach's alpha, composite reliability should also come out to be greater than 0.7, which would mean that so again this would mean that reliability, we said variance of true divided by the total variance of the true divided by the variance of observed, right? So that means there is at least 70% data, 70% of the items is can be attributed to the true construct EMP, right? So composite reliability, and composite reliability greater than 0.7 is a condition for convergent. That means all these items converge onto the latent factor EMP. So these are adequate or right items for the latent factor EMP. Similarly, you will compute CR for TO and you will compute CR for LEX, right? So this is the convergent validity computation. Then we have another